Good afternoon, everyone. How is everyone doing today? Good. So the topic is energy, and I'm hoping you'll have plenty of good questions for us. My name is Pari Kasotia. I'm the Deputy Director at the Solar Foundation. For those who don't know us, we are a nonprofit organization based in Washington, D.C. Our primary product is the National Solar Jobs Census Report. We look at the job impact of the solar industry in the US and also the economic impact of that. We also do other programs related to local governments to help reduce the market barriers and soft cost of solar PV. So we'll get started. I have a series of questions, but first I want our esteemed panelists to introduce themselves and just talk briefly about their work.
Thank you, Pari. My name is Mary Vincent. I'm an EIR at SK Telecom Ventures, so we look at hardware and software investments as well as AI. I also advise a clean tech investment firm that's publicly traded, and it commercializes technology out of the National Renewable Energy Laboratory in Colorado. So one of the latest investments is a wind software investment that makes wind turbines efficient.
Good afternoon. It's a pleasure for me to be here with you. My name is Audrey Lee. I'm a Vice President for Grid Services at Sunrun. Sunrun is the largest standalone residential solar company in the U.S. today. And I lead Grid Services, which means taking Sunrun's mission statement, which is a planet run by the sun, to a higher penetration of solar energy. And so we do that by working with utilities and wholesale energy markets to integrate more solar by integrating that with energy storage, aggregating these systems and using them as virtual power plants or non-wires alternatives so that we can really get to a goal of 100% renewables.
Good afternoon. My name is Miley Smith. I work for a company called Northgate Environmental. We're a small women-owned environmental science and engineering firm. And I work in the environmental field, environmental management primarily, the study, protection, and cleanup of groundwater. But my academic background is in geology. So when I heard the topic of this particular panel, the new gold, it reminded me a lot about this saying that we have in geology, which is, if it can't be grown, it has to be mined. And I've always had a sort of an issue with that statement because it's very apologetic for the inevitable destruction that occurs with mineral extraction. But it also acknowledges the reality that everything that we do, everything that we consider a technological innovation, really comes with an environmental impact. And we have to be cognizant of those impacts, everything from processors, chips, to photovoltaics. So, and the processing of all of those materials and those technologies also creates waste, solid waste, and water waste. So I always think of this one particular client that I have when I'm thinking about the environmental costs, the true environmental costs that come with these technological innovations and really some great leaps and bounds that we've made in our lives. So this client of mine is, they're one of the founding sort of fathers, mothers of Silicon Valley, and when they were getting started in the late 60s, they used this very common chemical to clean their silicon wafers. And at the time, this chemical was a few dollars a pound, and they used it very carefully. They used it in accordance with all of the laws and regulations at the time. They handled it, stored it, and disposed of it properly. But things changed, things that they didn't anticipate, changes in regulation, changes in understanding about this particular chemical and the science behind it, and the longevity of this chemical in the environment, and very small leaks and spills has resulted in, now they pay approximately $100,000 to $1 million per pound to clean this chemical out of the soil and the groundwater where it now resides. And they didn't consider this as part of their reserve because, of course, they were using it exactly as they were supposed to. So I bring this up not because I think we should be scared of technology or of these processes that lead us to these technological leaps and bounds, but just to remember there are unknowns out there that we can't possibly anticipate. Climate change is a great example of this, and that we need to maybe if we don't know the unknowns, we at least need to know where our decision points might be. We might change our behaviors, what that tipping point might be.
My name is Terry Jester. This is my 38th year working in the solar business. I was lucky in the early days to join a small company called Arco Solar and got to work on the very early development of solar modules and solar systems. Since then, I've continued to work in materials and operations, running various factories, and now run a company that makes silicon for solar modules. And it's really quite an interesting change from, as Miley said, about how you look at and manage materials for a business like solar, which has certainly grown to be quite an impactful business. I would say that being on the panel today was really important to me because I think all of these topics matter, particularly in a business like this where we're creating a new way of producing electricity. So I think the last thing we want to do is do anything that would be harmful to the environment. So thank you.
Thank you all for those introductions. So I want to start off by just talking about the technology in the clean energy sector. California leads the solar market with the highest number of installation. We are seeing a lot of wind penetration in the states of Texas and Iowa and some other Midwest states. The thing that we constantly hear about wind and solar is the intermittency and the reliability issues. I want all of you to touch on the technology and talk about how far we have come in addressing the intermittency and the reliability issues.
So one of the things that has to be mentioned is energy efficiency first, because that helps with the reliability. So for example, in data centers, so I actually did some data center energy efficiency work several years ago. And one thing you look at is the hardware-software process. How can you reduce energy use right now? And then after that, see if you need to do a hardware retrofit or a software retrofit. So same thing applies to solar or wind. So what things do you need to look at? So June of this year, you may have heard there was a Chinese province of 5 million citizens that went 100% renewable for 7 days straight. So most of that was hydro, and that also included wind and solar. California, like San Diego, electric is pretty high up there in the 30% range. So California is pretty high so far, but there still needs to be a long way to go. I think we need more storage, and that has to be scaled. We still need more wind and solar. That needs to be scaled. Well, one thing, going back to data centers and what's been done, is Google committed to 100% renewable energy this year, so 2017. And one of the ways they did that was to look at energy efficiency, but also to work with other providers to provide them power across this country and in the world. And so far they've done it, and it's 2017. So it can be done. We just have to move further and faster. I did want to talk about a few technologies, though, that are the 3 trends that are going to be game-change disruptions to make this happen. It's electrification, decentralization, and digitization. So it's the grid-edge devices that we have to look at. So it's the smart connected technologies at the end of the electric power grid. So distributed storage, distributed generation, smart meters, smart appliances, electric vehicles. So that will all impact the electricity system.
I completely agree. Yeah, I think we've arrived. It's happening today. We don't need to wait for technology. We don't have to wait for technology costs to come down. I think by combining existing technology like energy storage, energy efficiency, demand response with the intermittent wind and solar, we really can get to 100% renewable energy. My background's in electrical engineering, and I spent a lot of time in the government at the Public Utilities Commission. I really see the challenge today isn't necessarily the technology; it's really the market rules and market barriers and the regulation. And so, what do we need to do to incentivize utilities to invest in the structure and change the way that they do business, right? Instead of investing in natural gas power plants or upgrading a substation, how can we take distributed, as you said, distributed solar plus storage at individual residential homes and commercial and industrial sites, aggregate that, and dispatch those batteries? And I talked about virtual power plants before. How do you dispatch those aggregations? And you do that with software, which we have today. to replace those natural gas power plants. So on a hot day in the summer, like we had last weekend in San Francisco, instead of the utility dispatching a natural gas power plant to serve that demand, they could be dispatching solar plus storage units at individual households and serving that load directly at the distributed level, at the edge of the grid, as you say. And then I think also on the software, better data analytics, better weather forecasting can really help with that intermittency and get us there, as well as modernizing our distribution grid, right? So the grid that we have today is decades old, very old technology. How do we put in the sensors and the communications and the controls and the software so that it can work with the distributed energy resources that we put into a system that is more of a distributed model instead of a centralized model?
Thanks for that, those insights. I do want to switch to the environmental management of wind and solar. There is a lot of water that's required in the manufacturing and production of solar, and there are issues related with water quality. So Miley, given your expertise, maybe you can touch on that.
Sure. Yeah, there are actually billions of gallons of water that are used every day in this country to produce electricity across the nation. And huge amounts of that energy, in turn, is used to pump, treat, heat, and transfer water. So this is the very definition of a negative feedback loop. So there are many, many bright minds that are working on this water energy nexus right now. Local examples include Lawrence Berkeley National Laboratory and the Tomcat Center for Sustainable Energy at Stanford. These are minds that are much brighter than mine, but I can give you I can just share a few of the trends in water management from the energy sector and from other industrial sectors. First and foremost, and this is the most important development in decades, if not longer, is California now has a Sustainable Groundwater Management Act. So this is the first in our history that we have a legal framework for managing groundwater in this state. California is always at a net water deficit and will always be in a perpetual drought because we export our water not only for domestic use and because we are a semi-arid and arid state, but we export our water in the form of food, in the form of our agriculture. So water is a very big deal for many, many reasons in California. What the Sustainable Groundwater Management Act does is that it eliminates overdrafts. So it forces these regions that are groundwater dependent to balance their groundwater recharge and their pumping activities. So this is essential not only for energy production, but also for agriculture and domestic use, as well as for environmental needs. Other trends that we're seeing as far as water protection and water management in urban areas, there's a huge trend and focus on stormwater management. So managing stormwater not only for climate change resiliency purposes, but for recharging groundwater, for basically banking this as a resource for future needs. And also recycled water projects are increasing by a great deal, with some of the biggest recycled water projects coming online this year. This is more intensive in Southern California, but we're seeing it more in Northern California now as well. And then the other big trend that we're seeing is in wastewater treatment. So switching to an anaerobic process for treating wastewater, which is far less energy intensive than the current aerobic processes.
Maybe I could talk to this for a minute. I'm going to talk on a micro level of the factories that I've run. The first factory that I ran was in Camarillo, California, and the challenges we had there were the use of a lot of water, but then really with a very strict total dissolved solids limit, which of course I support, and it was ag land, so we were not allowed to discharge water, but it was incumbent on us to figure out how to use that water in the best way possible. Again, I'm talking within the four walls of this factory. So we were looking at ways how to run our compressors with waters that maybe had a little bit higher mineral content or dissolved solids than could be discharged, as well as ways to try to reuse processed water. I've run a factory in Toronto, Canada, where the regulations are equally as strict, and those challenges had to do with pH monitoring and pH stability band. And so we spent a lot of time working on how we could treat water in that factory, not only to reuse it, but perhaps filter out things that may be affecting processes and then reuse it, create the pH levels that we needed, and then treatment afterwards. The third and most challenging water problem that I've been dealing with is we're permitting a plant in Iceland right now, which is one of the most beautiful countries that you could ever imagine, surrounded by water, but definitely not a place that you're going to want to pollute any water. So we use a lot of water in the process that we're deploying there. We make silicon and we have a lot of cooling water. And so every attribute about the water is important. And so as we've looked at ways to not only clean the water that we use in the process, but also use the water that we create or that we are using in the process, use it again and again and again, as well as having a byproduct that the water ultimately ends up in that can be used for water treatment. So we've been very proud of the work that we've done at Silicor to basically draw a black box around our plant. Clean water comes in, and clean water or useful water comes out to create clean water. So just again on a micro level.
You know, I want to just comment on your remarks about the energy-water nexus and how it's not a positive feedback cycle, and I think there's a great opportunity there. So before I joined Sunrun on the residential solar side, I worked on the commercial and industrial side on energy storage, and we put in actually large battery systems and solar systems at wastewater treatment plants. And they, as you said, they use a lot of energy. They pay high energy bills. They pay demand charges to the electric utility. So being able to put in energy storage to help reduce those energy costs, but then also using that energy storage to help the grid. So they were part of a virtual power plant, as I explained, where the utility could tap that battery at the wastewater treatment plant and use it to help the grid and prevent outages also. So that's being able to find creative solutions that help both the customer, the wastewater treatment plant, the water agency, as well as the grid and all the customers on the grid is really the win-win solution to make these technologies economic, because you get multiple revenue streams, but making the whole system more efficient.
I have one quick thing. Department of Energy actually sent an email out yesterday saying that they will fund solar desalination technologies. And they're going to put out that request for whoever wants funding at the end of the month. So look for that if you're interested.
So while we are on the topic of environmental management, I also want to touch on the mining of the minerals that are needed from the manufacturing of solar panels. So, when we talk about the solar industry, our critics point out to the mining practices, especially in the developing countries. So maybe the panelists can touch briefly on what are the challenges there and what are some of the best practices we should consider.
Just a design life cycle. I would definitely make sure that your company or the partners that you're working with are looking at the full design cycle. I know when I actually had a company and I was CTO, I was having to choose what products I was going to have in this product, but I was touring factories in China and in Taiwan looking for the best manufacturer. So I wasn't only looking for quality being manufactured, but I was looking at where this product is sourced, how the folks were treated, but I was also looking at the whole design of that product itself. Is it a bad chemical that could damage somebody's health? Because maybe I could be eventually liable someday. So I was looking, as a person who was choosing these products to make sure that it fit with the sustainable and quality of the design life cycle.
So I'm very glad to hear that. We often look to life cycle analysis when we're talking about sustainability, not only from a manufacturing and supply side, but also in the industry that I work in, which is environmental investigation and environmental restoration. We also look at the life cycle, the process of what materials do you need to accomplish your goal, and so like the cradle to grave process, and what waste you're going to produce as a process. So for particular to the solar industry, there's sort of three main areas that we look at when we're evaluating those environmental trade-offs. There's, of course, the construction process for constructing utility, and this is similar to really to most construction projects where we're looking at grading, road construction. This creates land erosion, sedimentation, dust. There could be noise and aesthetic concerns. There's also water use. Of course, there's vegetation removal. There's habitat destruction and fragmentation. All of those things get examined in a permitting process, and you mitigate or you have controls to try and minimize that. In the operations arena, the big concern really is again habitat loss and habitat fragmentation, but also water use, and this is more common in concentrating solar power. Photovoltaics, at least to my knowledge, uses a very minimal amount of water, but these CSP systems, I mean, they're using on the order same amount of water as coal and natural gas combined during their operational periods. My concern as an environmental restoration specialist, however, is in the decommissioning stage. So to the best of my knowledge, when solar utilities are decommissioned, they follow a very similar model to the mine reclamation process. So you're restoring basically the topography. You are going to be restoring vegetation, the landscape through grading or removing roads. But what is happening on a much different scale is you have lost biodiversity, you've lost total organic carbon in the soil, there's soil compaction, and so while your solar site, your utility site, has a lease on the order of 3, 4, 5 decades, the rehabilitation, the restoration of these ecosystem services in organic carbon, biodiversity, soil compaction, to restore those services is going to be on the order of hundreds, if not thousands of years. So, you think as a geologist that I'm most interested in rocks, but really what I'm most interested in is time, because we're talking about two very different time scales. And so my goal is always trying to bring those time scales a little bit more closely together by trying to think ahead about what you can do to prevent some of those losses that really take, they're going to outlast our lifetime by many, many years.
If I could just add, I once took a tour of the desert in Southern California with some environmental groups, and at the outset of that tour I thought, solar in the desert, it's not going to harm anything, but really when you actually go visit, you can see disturbed land and untouched land, even in the desert, and it's very different, the kind of habitat that's out there. So just because it's desert doesn't mean there's nothing out there. There is real habitat, and it takes, the environmental groups are saying, it's better to install the solar at land that's already been disturbed. That's marginally better than to touch undisturbed land. But then I totally agree it could take 100 years to bring it back.
I think the other part of what's been difficult in the metals and mining industry is it's a very energy-intensive process. And so one of the things, there's been a lot of studies done on energy payback analysis for all different kinds of renewables, and solar, of course, stacks up very well there with a year or less payback, depending on which type of technology you're using. But a lot of those studies don't go all the way back into, so for instance, in our process, we don't mine quartz, but we use a material that has used mined quartz. So the way you make silicon is you get quartz out of the ground, you strip the oxygen off. That's a super electric intensive process, and then that silicon, which has had the oxygen stripped off, is what's refined to make silicon for solar cells. But when you look at the energy balance, you really need to make sure that these processes create more energy, and by that I mean the solar panels themselves, they live for 25 to 40, maybe even longer years. So in the case of every material that you use, you should look at energy consumed in the case of metals and mining, going back even to sort of the quartz that's used. And I think the good news is that it has a very positive energy payback, but I don't think that was well understood when the processes were developed.
Okay, so we touched on the environmental aspects of clean energy technologies, and I think those who are proponents of clean energy have to recognize that we have to address the environmental challenges of it to really make it green technologies as we know it. So I want to switch back to the deployment of clean energy technologies. And we are seeing a lot of solar in the residential sector in California, in Massachusetts, in North Carolina, lots of states that are doing really well with solar energy and wind. I want to touch on, in the next 5 years, what are the big game changers, or what are some of the key ingredients that we need to see for us to get to the goal of 100% clean energy that we are envisioning?
I think I addressed a couple of the game-changing technologies before, like with distributed storage. But one thing I think I wanted to talk about a little bit more in depth was the electric car revolution. And if you're going to have an electric car, you already have storage. That is going to be connected to the grid, so you can keep that energy for you maybe to power your house. Or here's another thing. So actually I was at this conference last year in Dubai, and I spoke on IoT, microgrids, and blockchain. And so interesting concept that people are talking about now is instead of selling your energy to the grid, like with solar or your storage, maybe you can keep it yourself, and maybe your neighbor wants to power their electric car off of your house, and you can use blockchain to do it. So there's a lot of interesting business models out there relating to storage.
I think a game changer that we'll need to work on in the next 5 years is the utility business model. The way it works right now, and I talked about this a little earlier about a very centralized system. We have a power plant sending electricity down to the users. That's rapidly changing and has changed already to a more distributed system. And so the grid that we've created was built on that old system of a centralized power generation. And so now we need to change the way we incentivize utilities. So utilities today are incentivized, they earn a rate of return on the physical infrastructure that they put in. So when they put in a new pole, when they upgrade a substation, they earn, whether it's 6% or 7% return on that. And that's how their shareholders make money. But we don't necessarily want to do that anymore. We want to incentivize other companies to participate, for distributed energy resources like solar and storage to participate. So how do you incentivize utilities to work with these new energy companies and continue to incent? We need the utilities there. We need them to continue to provide a reliable grid for us to change the new model. And so, we need incentives for utility. We need state incentives. So there's a regulatory aspect of it. There's the changing how utilities earn a return and stay profitable. But then also the new world we're facing is customer choice, right? You talked about IoT and blockchain. How does the electricity part of a customer's home, their solar panel and their battery interface with their Alexa and their Samsung Smart Things and control their HVAC and do energy efficiency and demand response. So all of that, I think, is very exciting. That's going to happen over the next 5 years. How do we continue to give customers choice in this, that they don't just take the electricity that the utility gives them, but that they have, they can decide how renewable their power is. And so regulators need to continue to push innovation in this, allow innovation in this space. And then I think as an energy company, we need to compete and we need to bring interesting choices to those customers.
I guess I would just say I think there's a couple of different ways things are going to change. Obviously, we've talked about storage and ballasting, but I think when you look at the electricity grid and use, it's going to become more like a neural network where sort of supply and demand is controlled by a much more sophisticated set of control algorithms. I think it's going to be important for response time of equipment to improve. I look at, I know when I was in school, mechanical engineer and studying thermodynamics, when we looked at power plants, the response time of turbines and various other things they're not meant, or they haven't been designed historically to turn off and on quickly. And I think when you look at things like the duck curve in California, where things, they have to respond in such a way, the power plants to come down and come up. There's a lot of lag time there, and I think there's going to have to be ways for things to respond quicker. And it's, again, just an engineering challenge, and first acceptance that it's a problem, and then I think working on the solution.
So you mentioned a great comment about the utilities. So they're losing money because they want to make sure people are efficient, but when you do that, you don't sell as many electricity cells. So one thing that some utilities are looking at is partnering with companies like O-Power. So O-Power educates the consumer on how much energy they're using. But also, in addition to that, there's a marketplace that's starting to be created between the utility and O-Power to say, these are some energy-efficient appliances you may be interested as a consumer. These are some interesting solar companies you may want to look at, like Sunrun's pretty awesome. So these marketplaces are ways that the utilities could still make money while us being energy efficient as well.
So we have about 8.5 minutes remaining. I'll ask one final question, and then I'll open the floor to the audience to ask questions. So in a minute or so, tell me, what can technology sector do? So companies that you're representing, what can you do to enable a more clean energy friendly markets?
I guess I can talk from the investment technology side. So a lot of the things that you look at sometimes, even just from a traditional investment model, you look for technologies to solve problems. Well, a lot of the investments that investment companies have made are energy efficient investments for data centers, for IoT, both for industry and consumer. Industrial IoT is very hot, especially in manufacturing, mining, so if you can save energy, water, and those environments using IoT technologies, you don't normally think of it as a clean tech technology, but it solves a problem to reduce energy use, to reduce water use. So these investments have been happening for a long time. So if you have a compelling technology that could address these problems, please talk to investors, companies, these partners who may want to use your technology now, because these problems need to be solved.
I think solar companies like Sunrun and many others have not traditionally worked very closely with utilities, especially when solar penetration is low, when it's 2%, 3% penetration of rooftop solar. It doesn't affect the grid in a big way. But now that solar penetration has increased, you talked about 40% solar, 40% renewables in San Diego Gas and Electric. Now that renewables are a very major part of the grid, companies like Sunrun and other energy companies need to work much more closely with utilities and the regulatory commissions as well to figure out how do we make this whole system work with the diversity of energy technologies that we have, so that they can be integrated and talk to each other. We can definitely do this with software and technology. It's just a matter of coordination. So that's what we're focusing on very heavily in the near term.
So obviously I don't work for the solar industry, but from my perspective in my industry in the environmental restoration, I would say that we really must not sacrifice green fields for bright fields. I've seen figures that place the majority of solar utilities in native or natural areas, scrublands and shrublands in California. Nearly 30% are in agricultural areas. Only 15% are in developed areas. So I would like to see these renewable utilities building their projects in developed areas, or at least closer to existing transmission lines and existing infrastructure. There's EPA has a great project for doing this called Repowering America, which is an incentive to place renewable energy on already impacted land. So this could be closed landfills, it could be Superfund sites. It's, these are areas that are already affected by humans, so they already have existing infrastructure and existing issues that need to be addressed, like mine sites. So it's lessening the competition for open space, and there's also, existing infrastructure that I mentioned that can be leveraged. There's tax incentives, and these properties are also often lower cost.
So I'll just address what Silicor's doing to increase renewable energy adoption. Turns out that 20% of a solar module's cost is the acquisition of the silicon just before you do anything with it. We're cutting that in half, and again, that's just another part of continued cost reduction and improvement of the rate of return for folks that install solar systems. There's still a lot of good rabbits to be pulled out of the hat to continue to reduce cost, and we're focused on one piece of it.
One thing I wanted to mention for the entrepreneurs out there, so there's a program called CalSeed. It's out of Oakland. They've partnered with the California Energy Commission. So if you have an interesting clean tech technology and you need a bit of funding, they could potentially fund you. So they just went through their first round of companies, and now they were looking for their second round. So look up CalSeed. It's a good organization.
Well, thank you all for your wonderful remarks and insights on the solar industry and touching on the environmental aspects of it. We have a few minutes remaining for questions from all of you. So if you have any questions, there is a mic out there.
My total career has been in the electrical power generation, various fields, coal, nuclear, gas. Now I have solarized my home totally. I'm a very great enthusiast about renewable energy. My question is, all along I have been hearing about the silicon as the base material for the solar panels. What are the alternative materials you are looking for instead of silicon?
I'll answer that. There have been a lot of alternative materials that have been developed over the years, certainly in the early days, amorphous silicon, now cadmium telluride. First Solar is the biggest solar company in the world, right? They don't make silicon modules. So thin films and copper-indium selenide, there's various stacks that people are using. And then there's all kinds of material stacks used in concentrating solar power. So there's an awful lot of work, a tremendous amount of work going on in sort of micro materials and nanostructures. So a lot of activity in the universities, a lot of activities at the labs. Right now, 90% of the solar modules that are made and sold are silicon. So there's still a lot of work that can be done to continue to reduce that cost. But there's no lack of work on different material structures out there at this point.
Another question I have, in case others allow me. Right now, the typical arrangement in a domestic solar production is the solar production which gives you DC power, then there's the inverter, and then goes back to the typical standard 110 volt system. There's a lot of loss of efficiency in this process. Now, what's being done to change that total system where we can use the DC production directly from the solar generation rather than inverting it back to 110?
I think that's been worked on for a long, that's been ideated for a long time, kind of using the DC side. We do have a product called the Bright Box that is a solar and storage system, and so the battery and the solar panel are actually behind one inverter, and the battery is actually charged from the DC output of the solar, and so that does, reduce some of those losses. But then it still does have to go to AC to go to the home or go back to the grid. I think it's. I've heard that there's work being done on newer developments where you can kind of start fresh, or developing economies in more rural areas where they can think fresh. It's just hard to retrofit an existing home from AC to DC on the residential side, but if you're creating a new home, or if it's a developing country application where there are only a couple appliances or you can incentivize the manufacturer to create DC versions of all the different appliances. I think there's just, we've gone down this route, and so it's a little bit hard to switch back, but I think it's still an exciting area to explore.
Hi, my name is Margarita Colmenares, and I'm a co-founder of a startup that's working at the nexus of energy and water using renewables. And I wanted to ask, besides CalSeed, what other ideas you have for us? We are seeking impact investors with patient money.
If you want to talk later, I would love to give you some advice. Yeah, but CalSeed is like one of the main areas. And so what they do is, in addition to funding, they will partner you up with a clean tech accelerator. You can still apply to Clean Tech Open's accelerator on your own, so you don't have to be accepted to CalSeed. But Clean Tech Open has a great network of investors, mentors, and it's all free.
I'm familiar with that.
Okay,
I was
great.
part of a startup. We were this other startup, but we made it to the semifinals.
Great.
And as far as CalSeed, we did apply first round, so maybe we'll get luckier second round.
Good. That's excellent. Persistence pays off. Nancy P. Fund is one of the first women clean tech investors. Have you heard of her?
Yes.
Okay. Have you talked to her?
No.
I would talk to her. But we could talk more after.
Okay. Anyone else?
Hearing no other comments, any other questions from the audience? If you can come to the mic, please.
Hello. I was wondering, in clean technology, do any of the companies look at the biological process of how to manage energy, to clean energy, or to provide energy? For an example, like synthetic photosynthesis, or
Can you repeat your question and to the mic?
Sorry. I was wondering, are there any clean technology businesses that are looking at the biological process to manage energy, or to produce energy, or to clean energy? Like how plants take in the sunlight, like photosynthesis. Are there any companies thinking of using synthetic photosynthesis to, distribute energy or anything?
My husband actually did his PhD at MIT, and he did a project on that, synthetic photosynthesis and hydrogen production. I'd be happy to, put you in touch with him. I'm sure he has papers and knows companies doing that.
For an example, the biomimicry industry, I was just wondering, are there any collaborative efforts or any joint efforts in solving some of those water problems or anything?
Since you mentioned biomimicry, that you should contact them and ask them your question. I'm sure that they've looked at it. Yeah, they're a good organization.
Thank you.
Please join me in thanking our esteemed panelists for their insights today. Thank you.